Hello, in this lesson, we're going to talk about how to solve simple trig inequalities. Since we've been talking about the if statement, right? For a function, right? The domain range determined, the rule is set. And in the trig inequality case, there are if statements as well, okay? For example, we're going to see some examples. Excuse me. So on the stage of ARD, right? In the case of if statement, right? So we have the definition of all these 6 functions. Take the first example. Okay, you say solve for x. Okay, where we're given, let's do A. Okay, so we don't get confused with x. So sine of A is larger than 0. Let's do larger than or equal to 0. How about that? Okay. So what does that mean? What does that mean? It means that, so let's think out aloud. Right? What does this statement mean? Right? And how do we solve this inequality? How do we solve this inequality? So that's the question, right? That's the question. Well, for the sine case, right, we know the input is A. It's an angle, right? And we apply the rule of sine. And the ratio, of course, is sine of A. And we know the output is going to be positive or 0. We know the output is going to be positive or 0. What does that mean? Okay, we're going to look from two perspectives. The first perspective is from the definitions perspective. Okay, from the definitions perspective. Unit circle or not. Okay, you can look at unit circle or not unit circle. Okay, so let me make a rectangular system, which is not unit circle. Well, it could be any circle involved, right? But the definition applies. So we're going to put these two together, right? One as an example. And so here I'm going to just to demonstrate how do we think of these questions. Right there. -5. Right, and we want sine of the sine ratio. We want the sine ratio, the output to be at least 0. Right. So if you look at those examples on those blue numbers are the sine ratios, right? Are the sine ratios. If we want them to be at least 0, so those terminals are going to be what? What are those terminals? Those terminals will include 0, right? All of these terminals, right? All of these terminals. And all of these terminals all the way up overlapping with pi. It doesn't go under because underneath the x-axis, those ratios will all be negative, right? So you can see the solutions are going to be where? The solutions basically are angles that terminates from either this terminal or all of the terminals in between. Okay, any terminal in between, many of them. So, and the respective angles. Does that make sense to you? So angles terminate on, the standard position and everywhere, right? The same thing. So all of these terminals will be solutions, Okay. Then we go around from here. And all of these will be, the ratio at least is 0, right? Do you see that? So this is from the definitions perspective, but we have another amazing perspective. We'll have another amazing perspective, which is the graph, So let's look at the sine curve. Okay, so let's look at the sine curve. Okay, look at the sine curve. How do we read the sine curve? We spend all that time, right? We spend all that time graphing these curves, right? We graph all of these curves. And this is the time we get to use them. We get to use them to enhance our understanding, right? So if you look at the sine curves, and I'm going to make the interval just a little bit longer, right? Just a little bit longer. Where does it tell us the output are non-negative, positive, or zero? Right? Remember those blue numbers, right? Those blue numbers, hold on, let me put it here. Okay, I'm going to put this one over here. Okay, I'm going to put the unit circle right here. All right. Recall the making of sine curve. Recall the making of sine curve. It's all the blue bars, right? All of these blue bars. Oops, that's not blue. I need the blue bars. Okay, for each arc length, right? At 0, which is 0 here, half, right? Pi over 6. And we have a pi over 6 somewhere, right? We have pi over 6 somewhere, right? All of these blue bars, they're corresponding to each other, whether they're special or not, okay? Whether they're special or not. So we have all of these blue bars, right? All of these blue bars. And all of these blue bars are positive or 0. Including the 0 here, right? This one, and all of these. And that's making of the sine curve. Does that make sense? Okay, so all of these are non-negative, positive or 0. So from 0 to pi, in other words, this entire piece is non-negative, is positive or 0. Okay, including these two dots, Okay, and so each one of these inputs, right? Each one of these numbers on this interval, right? That is a solution. 0 is a solution, right? And pi over 4 is a solution. Yes. And and pi over 2 is a solution, and all of these are solutions. You see that? And none of these are solution because these ratios are negative. And all of these are solutions, right? Hold on. All of these are solutions because their ratios are those blue bars. They're all non-negative. They're all non-negative, positive or 0. Do you see that? So that's how this picture and make it so obvious for our solutions, So what will be the solution? What will be the solution for sine? Right? What will be the solution for sine? Sine of A at least 0. Right? So if this is true, we know this is if statement, right? The output are all at least 0. So the solutions comes in intervals, right? The first interval we recognize is from 0 to pi. 0 to pi, all the numbers in between, okay? So solutions from 0 to pi, from -2 pi to pi, right? So another interval would be solution, negative 2 pi to negative pi, right? That's a solution. And what else do we have? And the next interval, right? Then the following interval, which is from 2 pi to 3 pi, right? From 2 pi to 3 pi, right? So we have many such intervals. We have many such intervals. Do we have a pattern for it? Do we have a pattern? Do we have a pattern for it? Patterns. It's always you see 0 to pi. There's no pi to 2 pi, right? Because those are negative. So this 0 to pi and then 2 pi to 3 pi. So it's even number of multiples of pi. Okay, so the pattern would be the even number. So 2k pi, right? To 2k plus 1 pi. Okay, so 2k pi plus 1 pi. Okay, 2k plus 1 pi. And k is going to be an integer. Integer including 0, -1, +1, and so on and so forth. Okay, so you can see even number multiples of pi, not odd number, because these are negative. See, these are negative ratios and these are positive ratios, right? So that's how we explain our solutions. So how do we show our work then? Right, so how to show work? This is how you show work if you use this method. Okay, how to show work? In this case, actually using the curve for sine is most convenient. It's actually more convenient than than the unit circle. So you can use either one. You're going to identify those, but I'm going to show you the easiest way to show work. Okay, so I basically take this interval, right, and I wrote down the question, right. Is solving for A. We want to identify all the possible inputs, right? So if this is true, right? So what are possible A? So find all possible A, right? Such that the sine ratio are going to be at least 0. Okay, so that my solution would be, I can show the picture, right? So I would just indicate, let me do something. Okay, so I'm going to point out, I'm going to put some dots on the curve. Okay, I'm going to put some dots on the curve. For example, I want to put a dot here and there where there are solutions included. So I'm going to put these dots on so one of them is 0, 0. I'm going to put these dots, and the next one will be pi 0, right? And the next one is 2 pi 0, right? So these dots, and from here to there, those numbers, those points have solutions. Those points inputs are solutions. So it could be -2 pi 0 and -2 pi -pi 0. And I also, whoops, what did I do? Where are those dots? Negative, oh, dots. Okay, red dots, there, red dots. Okay, so those are a solution, but I also going to mark some positive signs. I'm going to mark some positive signs. Okay, so I'm going to use the software to mark this, the positive sign. So these are positive, right? These are positive. So I'm going to mark the positive sign and this way. Okay. So this is positive. This is -5 and 0.75. Let's see if this will work. Positive, right? So you can put you can put a bunch of positive sign there. Or you can do these, right? These are positive, right? These are positive, and these pieces are positive, meaning the outputs are positive. So the picture tells us when it's above x-axis, that's a positive output. When it's below x-axis, those are negative output. So by putting these signs in place, you have shown the reader, you have identified. So let's put one more here just to, so we can have it, right? We can just have it. Here, I'm going to put a positive sign, and this one should be, let's see, 2 and 0.75. I just want to put those numbers there. Okay, so this piece is a positive, right? Or you just put a giant positive sign indicating this is a positive, this is a positive, that's piece negative and negative. From this picture, right, you have demonstrated and illustrated to the reader that you recognize these are positive, positive, negative, negative. Those are equal to zeros, right? Those output equals zeros. And then you just tell the reader the solution. So solution would be like that. That's how you show your work. That's how you can show your work. So this is solving a simple inequality like sine of A, right? For similar reason, you can work with cosine, tangent, cotangent, and so on and so forth, right? So let me give you another, let us look at another example, right? Another example, say, I want to solve for all the values of angle such that sine of x equals less than 0. Less than 0. What if it's less than 0? Then you certainly can recognize it, right? What are the negative? All of these are positive bumps and these are negative bumps. So the solution we want are negative, right? The rate we want the negative ratios. We want negative ratios. So the solution would be this interval, right? This interval and that interval, right? Not including those red dots. So how do we show that it's not including those red dots? We're going to put those red dots as circles. Okay, so this time we're going to change them to circles. 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 And circles. Do we have more? Yep, that's it. Circles, right? So what will be the solution then? What will be the solution then, right? This is from pi to 2 pi, right? So you can list the solutions. Solutions. So the solutions are now does not include the endpoints, right? So from pi to 2 pi, that's one solution. That's one interval of solution, right? And you can say and more, right? And there are more. And from negative pi to 0, from negative pi to 0 Do we have more? We certainly have more, right? So we can keep going in to the right and keep going to the left. So let's see how we identify those bumps. Okay, so let's see how we identify those bumps. I'm going to expand it. Okay, so I'm going to make the view a bit larger. So that let's see, say this is a negative 10. This is positive 10. Okay, so we can identify more intervals. So those intervals of solutions are going to be, of course, those are also circles. And so this is pi, this is a negative pi to 0, right? So let me switch the order, right? So you want to go from left to right, right? So this, and in this direction, it's going to be here. So you're going to recognize, what is this interval, right? This is negative 2 pi. So this is negative 3 pi, right? So negative 3 pi to negative 2 pi. See, negative 3 pi to negative. So all of these are solutions. I need to put some more dots, more circles, sorry. Okay, negative 3 pi, 0, that red dot, red circle, not red dot, right? And one more, and this is, this would be 2 pi, 3 pi, right? So 3 pi, I think you got the idea. You got the idea by this time. It just, but you have to express it properly. So there are lots of intervals before, in before, right? And there are also lots of intervals after, and we want to find the pattern. So this so the solution we identified are going to be, this is a solution, right? All of these are solutions for A, right? And the ratios are negative, and all of these are solutions for A, for the inequalities, and these are solutions. We're basically just describing these intervals. We do. Okay, and we try to find pattern. So from negative 3 pi to negative 2 pi, from negative pi to 0, right? From pi to 2 pi, and then, and this is 0 pi, 2 pi. So from 3 pi, okay, so this is going to be 3 pi to what? To 4 pi. You see, we always start with what? An odd number multiples of pi. So we can express the solution in general form as 2k plus 1 pi on one side of the interval, right? Hold on. That interval. Okay, and whoops, this is, and 2k plus 1 pi, and then, and ended at even 2k pi, and that is a open interval. That's an open interval. Does it work? For example, when k equals to 0, we get 1 pi, right? When k equals to 0, let's see, we're going to make sure it works. Okay, we have to make it works. So when k, so I'm going to check, I'm going to double check. Okay, so how I'm going to verify if I got it right, right? So when k is equals to 0, right? So we check if this is the one we're getting. When k equals to 0, that's going to be pi. K is 0, pi to 0, that's not right. Pi to 0, that doesn't work. Actually, we made a mistake. So how about we do minus 1, 2k minus 1. So when k equals 0, and negative pi and 0, Negative pi is 0. So negative pi is 0. So when k is 0, you see when k is 0, we get 2 times 0 minus 1. So it's negative pi on this piece. And the 0, right? So we got negative pi, 2 pi. Negative pi is 0. So this is matched. When k equals to 1, when k equals to 1, so 2 times 1 minus 1, that's pi, and 2 times pi. So we match this one. When k equals to 2, right? 2 times 2 is 4. 4 minus 1 is 3. And then this is a 4 pi. So this will be the interval. Okay. So how do you check? How do you check if we got the right answer, right? So I'm going to come back to show this to you. You guys should do it now. No, I will come back because we're talking about the patterns, right? You guys know the intervals, right? So we're going to check whether this pattern is correct, right? Because you're thinking that I changed from 2k plus 1 to 2k minus 1 because 2k plus 1 doesn't work. So how do I check it works? How do I check it works? These work typically done on the scratch paper, right? So when k equals to 0, when k equals 0, and this interval will be what? K is 0, right? And k is 0, right? So we end up with what? We end up with 2 times 0, that's going to be 0. 0 minus 1, that's negative pi. And 2 times 0, then that's going to be 0. So that interval is one of those, right? So then we continue to check a couple more to confirm our, so if k equals to 1, right? If k equals 1, look at what this pattern will get us to. So 2 times 1, and this is a 1, right? You substitute k by 1, and 2 times 1 is 2, 2 minus 1 is 1, so this is just pi. And 2 times 1 times pi is 2 pi. So that interval is in the list. You see that? When k equals to negative 1, okay, I'm going to take the same pattern and to check if I get what I expect, right? So k equals to negative 1. So this is negative 1. And this k equals to negative 1. Let's see what we get. And the interval is going to be 2 times negative 1 is negative 2. Negative 2 minus 1 is a negative 3 pi. And 2 times negative 1 times pi, this is going to be negative 2 pi. Do we have a negative 3 pi, negative 2 pi? Yes, we have one over here. So this is how we check. And of course, we're going to get 3 pi, 4 pi for k equals to 2. Okay, so let's just do one more. Okay, so when k equals to 2, we will substitute k by 2 in this form to see what we get. So k equals to 2. Okay, k equals to 2, right? And 2 times 2 is 3, is 4. 4 minus 1 is 3, so that's a 3 pi. 2 times 2, that's 4. We got it. We got it. So we got the right interval. So that's the solution. Okay, that's the solution. How do we show work? How do we show work? Okay, how do we show work? Well, when you show work, you don't have to show all these checks and stuff. Okay, so when we show work, okay, show work. Okay, show work for solving this inequality sign of A is less than 0, right? So what you can do is I will bring this picture into my, better yet, I will tell the reader the solutions The solutions are this piece. Okay, where k is any integer. But I'm going to picture on the curve each one of the intervals that are solutions. Okay, so that's what I'm going to do. Okay, so for example, I'm going to make the mark in this interval. Okay, so and that's going to be pi 0, right? Because from pi to 2 pi, from pi to 2 pi, pi to 2 pi, comma 0. And then I'm going to draw a line in between, right? And make it thick. There, so that's a solution. This is, I'm indicating this interval, every number in this interval, which are, you know, angles or radians of the input to sine, every point in this interval are solutions, not including the endpoints. It doesn't include the pi or 2 pi. So next I'm going to mark this interval. Okay, that's from negative pi to 0. So this marking I'm going to do, okay, right here, so negative pi to 0. See, that is marked. And so I continue to mark these intervals. Okay, continue to mark these intervals. You know, we could have marked in the previous question we did. Let's mark the next one. Okay. And what this interval? This is from negative 3 pi to negative 2 pi. There. So we mark that, we mark them, and we can, you know, you can continue to mark it, but this is sufficient. This is sufficient. So in terms of how to show work, and this is how you show work. You see, it's very visual, and you need to give the intervals. Okay. In the process, if you need to, you know, do the listing and checking, of course, go for it. But I would put those on the scratch paper. So let's go back to do example number 1 with the interval marking. Okay, I think I would like to mark those intervals too, but these interval will be here, right? And there, okay? And then we include the endpoints, okay? We include the endpoints. But anyway, so this will be better. These kind of marking would be better, right? So 0, 0, pi 0, and I'm going to mark it with golden and thick. Okay, so that's one interval being marked. And the next interval being marked, that's from negative 2 pi to negative pi. So negative 2 pi to negative pi. That's also marked the same way. You see, this will be this is a better in terms of showing solutions. And of course, we already have the solutions here. Okay, if you guys have any questions, please don't hesitate to reach out to me. And I put these solving equations and inequalities together because they are the same topics. They're the same topics. Knowing the output, so we do DRA. So this is the way to do DRA. Okay, it's actually very convenient to do it on the curve instead of doing the unit circle. Can you imagine how would you do the unit circle on the second question? We can still do it for sure, right? We can still do it for sure. It's just this time the ratios are going to be negative, all of these, right? All of these. So your interval is from pi to 2 pi, right? And then you go about from 3 pi to 4 pi, right? You can still get it. And because they correspond to each other, but it will be much easier to do it on the curve itself, right? So that's how to solve the inequalities of this sort. Okay, that's how to solve inequalities of this sort. I'm going to do one more for you. I'm going to do one more for you for cosine. Okay, so that's example number 3. Suppose I want to solve the inequality, say solve, okay, for A, right? Where we have a cosine of A is larger than 0, for example, cosine, right? So we already know the drill, but if we do the unit circle, what will be the solution? You look for the red number, which are negative, right? So these red numbers are negative. So from quadrant 2 to quadrant 3. So between pi over 2 to 3 pi over 2. And you go around, and then there's a 5 pi over 2, 5 pi over 2 to 7 pi over 2. So that's the solution. But if you do the curve, right? If you do the curve, cosine curve, right? If we do the cosine curve, okay, it's much easier, isn't it? Okay, so let's draw the cosine curve. Okay, draw the cosine curve. I'm going to put the cosine function in place, and we want cosine to be positive, right? And so corresponding to the from pi over 2 to 3 pi over 2, that's from here to there, right? You see these two dots between, that's negative, that's positive, that's negative, right? You see, that's very obvious, right? And we want, so this piece is a positive, and these two pieces are negative, and there are many, many such pieces to the left and to the right. And so there are lots of them, right? So you just choose those intervals. For that reason, you have to identify all of these points, okay? So now I'm going to put it under, right? I'm going to put it under, and I'm going to just put just a few more, say negative 10. Okay, and that's positive 10. I don't want to make the lecture too long today, but oh wait, yeah, I had a typo. There we go, right? So we want them to be positive. So on this piece, right, we're solving cosine A is larger than 0, so the output is positive, right? So that's what we want. You can see the use of curve, right? So A is the input, right? So after this, we're going to be finished, right? So we basically want to have positive ratio. I want to have positive ratio. That's it, right? We want to have positive ratio. So we wanted the out to be positive. So this piece, right? So this piece, positive, positive, positive. So how are you going to describe the intervals? How are you going to describe the intervals? Of course, you're going to describe from here to there, right? Not including endpoints, and here. Okay, so let me just mark it. Okay, so this interval, not including the endpoints, and this interval, right? And this interval. And what do you think these are the points? How do you identify these points? You can use with the help of the interval, right? With the help of unit circle, this is negative pi over 2, this is pi over 2. Okay, and this is 3 pi over 2, and this is 5 pi over 2. And this is a negative. This is on these sides is negative, Okay, so it's negative 3 pi over 2, negative 5 pi over 2. So you get those points. So let's put those points in place. Okay, so one of them, okay, I'm going to just show you one by one. So from here to there, okay, so that interval, I'm going to mark it as negative pi over 2, 0, right? 2 pi over 2, 0. And that interval are solutions, not including the endpoint. So I'm going to put 2 circles. I'm going to put 2 circles. Okay, I'm going to put 2 circles at the end. Okay, so over here and dot circles. And another one, circle. Yep. Circles. So you do this for each one of them. You do this for each one of them. Okay, so let's finish. And from here to there, and oh, by the way, so let's express the interval. This interval right here is from negative pi over 2 to pi over 2, open interval, meaning pi over 2 and negative pi over 2 are not included. And then we work on this interval. This interval, that's going to be 3 pi over 2, 5 pi over 2, right? So we do the same thing. Okay. So 3 pi over 2, 5 pi over 2. You can use decimals. You can actually use decimals. Okay. And we have those. So over here, add an item. Right, so this is a point, circle, and another one, point, circle. There you go, so the other interval. So you're gonna do this one at a time. And this point, well, think about cosine is even, right? So you have, so that interval, we describe it, right? So that's gonna be 3 pi over 2. And this other one is 5 pi over 2. Okay. And this other one is on the negative sides, right? So you're going to union all of them. We start to see patterns, don't we? We start to see patterns. We do. Okay, we start to see patterns. So this side is a negative, right? So it's right here, and then we just have to put the end points there. I'm gonna see the end points there. And this is gonna be point, circle, one more. And there you go. And how do we describe this interval? That interval is negative 5 pi over 2 and negative 3 pi over 2. 3 pi over 2. And if you also notice that cosine is even, so anything you have on the right side, you have the same on the left hand side. You just swap these two numbers because the smaller number is on the left, a larger number on the right. So we have many such intervals. Excuse me, do we have a pattern? Yes, we do. It looks like there are odd number multiples of pi over 2, right? So in general, okay, we prefer to have some, right? So we're gonna have multiples of pi over 2, but odd number multiples of pi over 2. Take these for example. So this is gonna be 2k minus 1, okay, or up to 2k plus 1. 2k plus 1. Of course, we have to check, does it work? Does it work, right? So we're going to check if it works. Okay, so we find the pattern. So when k equals 0, it matches this one. If k equals to 1, this will be pi over 2. Wait a minute. This may not work, okay? For k equals 0, it works, right? If k equals 0, again, negative pi over 2, pi over 2. If k equals to 1, what happened? 2 times 1 is 2. So let's check. Okay, because we may need to do, we may need to just, make some adjustment. Okay, so when k equals to 0, I make mistakes, okay, guys? I need to check as well. So when k is 0, okay? So in this case, we end up with negative pi over 2, right? Because this is negative pi over 2 to pi over 2. So we got this interval. We got it. We got this one. However, okay, I'm doubtful when k equals to 1. When k equals 1, we should get some either one of these because they're next to each other, right? But let's see, if k equals 1, it doesn't work. So when k equals to 1, if it doesn't work, we have to make adjustments. So this is going to be pi over 2, right? So this is a pi over 2. And the other side is, this is going to be 3 pi over 2. 3 pi over 2. 3 pi over 2. Pi over 2 to 3 pi over 2. Pi over 2, 3 pi over 2. That's not a solution. Those are negative. So we're completely off. So this form is not right. So what do we do? Well, how about we add 2k plus, let's see, what should we do? How about we, if k equals to 1, how about we do plus 1 and this plus 3. Plus 3. Okay, so it's trial and error. Then if this happens, then you say, what? How about matching this guy? To match this guy, we have to make a k equals to -1, right? So this is -1, and it's 3. Okay, do we make that match? Yes, we do, right? Wait, this is a -1. This is a -1. Okay, so this, just remove this. Okay, we got it wrong. So plus 1. So for k equals -1, we change the form. Okay, we change the form. 2k plus 1. So when k equals to -1, and this is -2 plus 1, that's negative pi over 2. And for 2k plus 3, 2 times -1 plus 3, then -2 plus 3, that's +1. So that one matched. And let's see if it works for k equals to 1. So this is a 1, right? And this is a 1. And this is make 3. So 3 pi over 2. And this is 5 pi, 5 pi over 2. So it matches this one. You can see it takes some adjustment, right? So it looks like this one works. It looks like this one works, right? There's a lot to do on the scratch paper. For k equals to -2, let's see if we can match the other one, right? K equals -2 to see if that matches the existing one. So k equals to -2. I'm sorry, this is longer than I expected, okay? And what we got is that for -2, this is gonna make -3, right? So this is gonna be -3 pi over 4, 3 pi over 2. And the other one, and this is going to be, that's a -4. -4 to -4 plus 3, that's a -pi. And that doesn't work. Oh my God, we're in trouble. We are in trouble. I think I need to work on that. These two are consecutive odd numbers. Okay, these are consecutive odd numbers. So this is -1, a +1, and -3. And this one doesn't make the -5 pi. You know what? I'm going to sleep over this and I get to the answer next time. Okay. So obviously we can, for at this moment, okay, I don't want to take more of your time. This is already past our time in this lesson. And if you want to discuss this with me further, but I'm going to give you a closure. Okay, so the solution we're going to do, okay, we're going to show, we just haven't, I haven't found the pattern, okay? Show work. So if this question is given to us, right? Solving for A, right? So the solution you would show, you take this picture, okay? And you give these intervals. For now, is good enough. Okay, if you show work like this, you get the credit. Okay, I need to work on the patterns. I think I need to have patterns for negative number and for positive number, and I will get back to you on this next time. Thank you for watching. Have a great time. Until next time. Bye-bye.